Good morning, ladies and gentlemen. Let's review the chain rule. The chain rule is a rule to find the derivative of a composite function. We have been using this a lot, but I think it's worth a review. So here I have a function h of x, which is the composition of a function f and g. In fact, it is f of g of x, where g of x is the inside. F of x is the outside. The derivative of this composite function, the derivative of h of x, which is h prime of x, is equal to f prime of g of x times the derivative of g of x. So f prime of g of x times g prime of x. The derivative of the outside at the inside. So we leave the inside alone. We take the derivative of the outside and we leave the inside alone. And then we multiply it to the derivative of the inside. So this is your basic formula for the derivative of a composite function f of g, where you have the derivative of the outside at the inside times the derivative of the inside. A lot of students like the Leibniz notation of the derivative of a composite function. And here we go. I can look at it this way. If I have y is equal to this composite function f of g of x, I can look at y as being a function of f of u, where u is g of x. So u is g of x. If I put g of x in there, then I get f of g of x. And now I'm just going to take the derivative of the pieces. Here I have y is equal to f of u. Therefore, dy du is f prime of u. And I take the derivative of u. Du dx is g prime of x. And look what I'm going to do. I'm going to put these pieces into our formula from above. So g of x is u. I'm going to put u in for g of x. Let's color coordinate it. U. So now I have, if I have y, so y is this composite function. Y are the outputs of this composite function, and I differentiate this with respect to x, i.e. I get dy dx, and that's going to be f prime of g of x times g prime of x, and this is the formula from above here. Don't forget that. And where I've let u equal g of x, and I have g prime, so I have f prime of u times g prime of x, and now I'm just going to fill in the pieces. Well, what is g prime of x? G prime of x right here is du dx. I put u in for g of x. Well, what's f prime of u? Dy du. And here I have this Leibniz notation. So dy dx is dy du times du dx. So let's use this on a couple examples. This is in your textbook, detailed out in your textbook. Let's go back to this and look at this entire page. If you need to take a picture or pause the video at that point, you may. We're going to jump forward now and do a couple examples using the chain rule. Here we go. I'm going to zoom back out. And example number 1. Here I have a function of t, h of t. And what I want to do is find h prime of t. Well, if I look at this, I have two pieces, two terms. Here I have an outside of sine and inside of 5/6t. I have an outside of cosine, inside of 3/4 t. So at this point in the game, we should be able to say, hey, what's the derivative of sine? The derivative of sine is cosine. At the inside, don't mess with the inside. But what do I have to do? I have to multiply the derivative of the inside. What's the derivative of 5/6t? 5/6. And now I'm down here. What's the derivative of cosine? The second piece, the derivative of cosine is negative sine. Leave the inside alone. But I have to multiply it by the derivative of the inside, which is 3/4 t, and the derivative of 3/4 t is 3/4. Now we want to make, whenever we have a trigonometric times a constant, you want to bring that constant out. So let's clean this up by simply making the 5/6 come out here first. This is going to be cosine of 5/6 t. And we're going to bring this constant out in front. This is going to be 3/4, negative 3/4, the sine of 3/4 t. And you'll find some assignment problems that look exactly like this. Here is an example. The next example, I have h of x is cosine cubed of 3x minus 4. These can be difficult because there's 3 lengths. And I have decomposed the composite function for you. And here I have to look at, this is something cubed. And students do get confused on that. If I let y equal u cubed, and u equal cosine w, and w equals 3x minus 4, let's see if I can compose these pieces. Before I start taking the derivative, let's see if I can compose these pieces and actually get this. So what is this? This is cosine of w. Let's do this in black. This is going to be cosine of w, which is 3x minus 4. And then what is u? This is u. And what's u cubed? U cubed then is going to be cosine cubed of 3x minus 4. And that is indeed what I started with, cosine cubed of 3x minus 4. So that's just to verify that what I did over here, this decomposition, was correct. Now I'm going to use the chain rule because my objective here, this is a calculus class, my objective is to find h prime. So I'm going to erase this. No, it's true. So now, oh, look what I'm going to do. I have 3 links to this chain. What I'm going to do is right over here, I'm going to find these 3 easy derivatives. dy du is 3u squared. Du dx is equal to negative sine of w, and dw dx is equal to 3. So therefore, this derivative is going to be dy du times du dx times dw dx. And what could we say? Oh, well, if this was an output, h of x, this is the y is equal to h of x. And then what did I want to find? I wanted to find dy dx. And what is dy dx? It's this product here, product of these pieces. Now I'm just going to put these pieces in here. I have 3u cubed times, better put that in parentheses, sine of w times 3. Now I'm going to start back substituting what everything is. Well, w is 3x minus 3x minus 4. Keep in mind that's times 3. And what's u? U is cosine of w. So this is 3 cosine of w cubed. Well, what is w? W is 3x minus 4. That's what this piece here is. This is 3u cubed. U is cosine. W is 3x minus 4. I still have to multiply it by negative sine of 3x minus 4 times 3. And now I'm going to clean it up by bringing all the constants out in front. And I have this 3, I have this negative 1, I have a 3. So this is going to be negative 9 cosine cubed of 3x minus 4 times the sine of 3x minus 4. And I will tell you, so this is what h prime is. Many of you at this point, and this is kind of, this is kind of tricky. This was supposed to be a squared right there. Ease up, dude. This was 3u squared. Easy fix there. Easy fix. And I saw that because I was going to mention that you can look at this and go right from here at this point in your studies. You could, and many of you can, go right from there to the derivative, which is going to be 3 cosine squared 3x minus 4 times negative sine 3x minus 4 times 3, and then you can come up with your final derivative. This is kind of tough. It takes some practice. You have a couple good practice problems to do on that. Now we're going to look at a table of value problems. These are very, very common. So here I have two functions, two derivatives, their derivatives, and two inputs. So I have x input of 4, x input of 5, and here f, what this chart means is that f of 4 is 5, g of 4 is 9, f prime of 4 is 6, g prime of 4 is 5. I have f prime of 5 is 8. I have g of 5 is 4, f prime of 5 is 3, and g prime of 5 is 2. So we have to be able to read, to be able to do these problems, we have to be able to read the chart. Okay. So here I have what I want on part A, and there's a couple of problems that I have assigned that are similar to that, similar to this set of problems, which I'm going to go over now. So I want to find the derivative of g of f of x at x equals 4. Well, what is this? This is going to be, what's the derivative of the outside here? The derivative of the outside is going to be g prime of f of 4 times f prime of 4. Because I want all this to happen at 4. I could have found the derivative first and then put 4 in. I mean, we could do that. It might be easier to understand that way. The derivative of g of f of x is going to be g prime of f of x times f prime of x. Now I'm going to put the 4 in. So this is going to be g prime of f of 4 times f prime of 4. And we're going to be able to find these values in the table. What is f prime? F of 4. F of 4 is 5, so this is going to be g prime of 5. What's f prime of 4? F prime of 4, I must have erased it. It was 6. That's funny that I erased it. Prime of 4 is 6. So what is g prime of 5? G prime of 5 is 2. So this is 2 times 6. And this is final answer 12. So the derivative of g of f of x at x equals 4 using the table of values is equal to 12. Let's do another one of those. I'll actually do 3 more. Here I have the derivative of the square root of g of x at x equals 4. Let's find the derivative of the square root of g of x first. What's the derivative of the square root? Don't forget what the derivative of the square root is. That's going to be 1 over 2 square root. And we have found that. We've used that a lot. Don't mess with the inside. Leave the inside alone. Times the derivative of the inside. So the derivative of the square root of x, square root of g of x, is 1 over 2 square root of g of x times g prime of x. This is a simple chain rule. And if I want to find this derivative at 4, I simply put 4 in wherever I see x. So this is going to be 1 over 2 square root of g of 4 times g prime of 4. I'm going to go up to my table of values and find g of 4 and g prime of 4. G of 4 is 9. G prime of 4 is 5. This guy is going to be 9, so this is going to be 1 over 2 square root of 9 times, and g of 4, I believe, was 5. Let's go up there and check it. G prime of 4 was 5. And so now what do we have? We have square root of 9 is 3. 2 times 3 is 6. Pause the video. Take a breath. Come up with your notes. I'm going on to the next problem. Same value, same table of values, just copied here. 2 more problems. Here I want the derivative with respect to x of 1 over f of x squared. All of these are chain problems, chain rule problems. Before I take this derivative, what I'm going to do is take this f of x squared and put him on top, because it's going to make it easier to find the derivative. So I've taken f of x, which was squared, f of x squared on the bottom, and now I have, what I'm going to do is that's going to be negative 2. That's going to be f of x to the negative 2. Now I'm going to differentiate that. What is the derivative of something negative 2? The negative 2 comes down in front. We leave the inside alone. Negative 2 minus 1 is negative 3. But what do I have to do? I have to take it times the derivative of the inside. Now I'm going to clean this up a little bit by taking this guy and putting him on bottom. This is going to be negative 2 f of x cubed times f prime of x. What do I want to do? I'm going to put, wherever I see x, put 5 in. I'm going to jump up here. So this is going to be negative 2 over f of 5 cubed times f prime of 5. Well, what's f of 5? F of 5 is 8. So this is going to be negative 2 over 8 cubed. F prime of 5 is 3. So this is going to be negative 6 over 8 cubed. You can reduce that if you want. Okay, let's do the final problem on this video, which is the derivative of g of x plus 4 cubed. So the first thing I have to do is I'm going to look at what's the inside. If the inside here is g of x plus 4, so this derivative is going to be 2 times g of x plus 4 squared times the derivative of the inside. And what is the derivative? And I'm going to write it out this way. The derivative of g of x plus 4. What is the derivative of g of x plus 4? Well, this is simply going to be g prime of x. The derivative 4, derivative is a linear operator. You differentiate the pieces. The derivative g of the g prime, derivative 4 is 0. But keep in mind, we still have this 2 times this quantity g of x plus 4 squared. And this is times that. It's a chain rule. So what do I want? I want this at 5. So I'm going to put 5 in wherever I see x. This is going to be 2 times g of 5 plus 4 squared times g prime of 5. And I look at my table of values, and I see g of 5 is 4. G of 5 is 4. G prime of 5 is 2. So this is going to be 2 times 4 plus 4 squared times 2. G prime of 5 is 2. Well, this is going to be 16, and just to clean it up, 8 squared is, it's going to be 4. 8. 8 squared is 64. And I believe the arithmetic, you'll have to check my arithmetic, I believe this is 256. So I got a couple good table of value problems here. I'm going to go back in view and look at all the pages. So we've done table of value problems, 2 derivatives, table of value problems, 2 derivatives, 2 just good old-fashioned chain rule problems, and a brief discussion, a brief review of the chain rule.